Children, today we will start our discussion from heading Action of Sodium and Ammonium Hydroxide on Solution of Salts. So you all know that sodium hydroxide is a strong electrolyte, whereas ammonium hydroxide is a weak electrolyte. So weak electrolytes are the electrolytes which dissociate partially. Means ammonium hydroxide will dissociate partially, and that is why it will produce comparatively less number of hydroxide ions in comparison to sodium hydroxide. Okay, students. So this table is given here, and according to the first ion, which is calcium ion, and calcium ion is taken here in the form of calcium nitrate. So it can be any salt of calcium. Okay, here it is given as calcium nitrate. Okay, so calcium nitrate, when reacts with sodium hydroxide, it forms sodium nitrate and calcium hydroxide. Okay, so this calcium hydroxide is insoluble in excess of sodium hydroxide, and the PPT color of calcium hydroxide is white. Okay, students. Then second, magnesium ions, and magnesium ions are taken in the form of magnesium chloride. When these magnesium ions react with sodium hydroxide in the form of magnesium chloride, you will get PPT of magnesium hydroxide, which is dull white and insoluble in excess of sodium hydroxide. So when you are going to write the color of PPT of magnesium hydroxide, you will always write dull white. Okay, so it's not simply white, it should be dull white. Then ferrous ion. Ferrous ions in the form of ferrous sulfate reacts with ferrous sulfate with sodium hydroxide, forming ferrous hydroxide. And this ferrous hydroxide is dirty green in color and also insoluble in excess of sodium hydroxide. Ferric ion in the form of ferric chloride, forming ferric hydroxide, which is reddish brown PPT, and again insoluble in excess of sodium hydroxide. Copper ion in the form of copper sulfate, forming copper hydroxide with sodium hydroxide, and this copper hydroxide is pale blue in color and also insoluble in excess of sodium hydroxide. Zinc ion reacting with sodium hydroxide, forming zinc hydroxide, which is gelatinous white PPT and soluble. Okay, and as you can see here, zinc hydroxide in excess of sodium hydroxide, forming sodium zincate, and this sodium zincate salt is soluble in water. Okay, so sodium zincate will form colorless solution. The next salt of lead nitrate, it is forming lead hydroxide, which is soluble in excess of sodium hydroxide. Lead hydroxide is chalky white in color. Okay, students, chalky white. Then second part, reactions with ammonium hydroxide. So ammonium hydroxide reacting with same salt of the metallic ions and forming hydroxide, and then we are testing its dissolution in excess of ammonium hydroxide. Okay, students. So in the first case, calcium ions in the form of calcium nitrate when reacting with ammonium hydroxide, so no precipitate of calcium hydroxide is formed. Why? Because ammonium hydroxide is a weak alkali, weak base, and that is why it forms comparatively less amount of hydroxide ions. Okay, and these less amount of hydroxide ions not able to form PPT of calcium hydroxide. The next ion is magnesium ions. Magnesium ions are in the form of magnesium chloride, and this magnesium chloride is forming magnesium hydroxide with ammonium hydroxide. And again, this is dull white and insoluble in excess of ammonium hydroxide. Same way, ferrous ions forming ferrous hydroxide, dirty green PPT, which is insoluble in excess of ammonium hydroxide. Ferric ions are forming ferric hydroxide, reddish brown PPT, which is insoluble. Copper ions are forming copper hydroxide, which is pale blue, and in excess of ammonium hydroxide, it is forming deep blue or inky blue solution. Okay, students. So the dissolution of copper hydroxide in partial amount and in excess amount of ammonium hydroxide is very important. This reaction of copper ions with ammonium hydroxide in limited amount and in excess amount, this reaction is very important. So in excess amount of ammonium hydroxide, copper ions are forming a complex tetraamine copper ion, and due to the formation of this complex ion, tetraamine copper ion, they form inky blue or deep blue solution. Okay, students. Then next ion is zinc ion, and zinc ion is forming zinc hydroxide, which is white gelatinous or gelatinous white PPT. This zinc hydroxide is in excess amount of ammonium hydroxide is forming a complex salt, tetraamine zinc, which is soluble, and that is why turns the solution colorless. Okay, students. So you can see here in this reaction, when you are adding ammonium hydroxide excess in the medium of the first reaction, then you are getting tetraamine zinc sulfate, and you can take only zinc hydroxide PPT, and in this PPT you can add excess amount of ammonium hydroxide. Then again you will get tetraamine zinc complex ion. Okay, students, and this complex ion solution will be colorless. Then last ion, lead ions, and these are forming lead hydroxide, chalky white PPT, which is insoluble in excess of ammonium hydroxide. Okay, students. So as from here you can see the difference. Lead hydroxide is soluble in excess of sodium hydroxide, soluble, whereas it is insoluble in excess of ammonium hydroxide. Okay, students. So this difference you should keep in mind, that lead ions are insoluble in excess of ammonium hydroxide but are soluble in excess of sodium hydroxide. Okay, students, this much in this class. Thank you very much.